Um, hopefully that works. So everyone here, all the participants, remember to keep yourself muted. As I said, this is a recording. It's going up in YouTube, so for the best experience, remember to keep yourself muted. If you have any questions, put them in the chat. We'll have a 10-minute Q&A session. Well, for this one, we're going to have a long Q&A throughout a demo in the end. But if you just put your questions in the chat, they'll get answered. I'll keep an eye on the chat. And without further ado, welcome to Introduction into OnShape and FRC. I'll let the gentlemen introduce themselves.
Awesome. Yeah. You can probably go to the next slide, Alex.
Oh, yeah. Okay.
So a little bit about us. So my name is Andrew. As I said earlier, I'm a mentor on 1714 More Robotics and Team 930 Guanago Bears. I'm a senior electrical engineer here at MSOE, and I'm president of the MSOE Robotics First Alumni Organization.
I'm Everen. I am an alumni of Team 930 and also a mentor of 1714 More Robotics and Team 930. And I'm currently a sophomore biomolecular engineer at MSOE.
My name is Alex. I'm a mentor of 1745. I'm an alumni of 930, and I'm a freshman mechanical engineer at the University of Texas, Dallas. Okay.
So just a little housekeeping things we mentioned earlier. So our format is we're going to have like a short introduction presentation. Afterwards, we'll have a little bit of questions just about like the general like presentation topics. And then once those questions start leading more into questions about like specific OnShape features, we'll jump into our demo. We have a little short demo that we're going to give, and during that demo, you're more than welcome to pause us, and we can answer whatever questions you have about anything you might be seeing on the OnShape demo, or if you have questions about like how things work in OnShape, we can definitely show that. So, yep.
Yeah.
So topics to be covered. So we're going to be talking just like a really short introduction to what CAD is and why you should be using it, and how OnShape fits in that picture. We'll also be talking about some of the collaboration features in OnShape, because I know teams are really going to want to know about those for this season, especially with everything being virtual. And we're going to talk about some of the cool features in OnShape, including the MK CAD part library, some of the design features in OnShape, and then we'll finish off with some feature scripts.
All right, so first of all, what is this whole CAD thing that we're talking about? All right, so CAD stands for Computer-Aided Design. You may or may not have heard of it at this point. Essentially, it's creating a virtual representation of your robot in 3D space, so you can see how things look and potentially fit together to help you design your robot. And the big reason that you guys should care about this is that you can do a lot of your prototyping and iteration in CAD. You can see what mechanisms, how they're going to fit together, how they're going to interact. You're going to see, you can check if things are going to work or not by doing geometry and seeing, oh, we can't have an arm here because it's going to be interfering with something else. And I would like to also point you guys over to Andrew's 2D sketching presentation for more information on that after. It's going to be very useful for you guys to be able to design mechanisms even when they have those really close tolerances. It also is really useful because you're able to accurately reproduce parts and assemblies. This was more important in years past before Bag Day, when teams would usually make more than one robot. However, it's also very useful for creating spare mechanisms and spare parts for things that may break in competition. Along with that, CAD also allows you to use advanced manufacturing processes that are a lot more accurate and precise than other mechanisms, such as CNC, lasering, or 3D printing. You'll see in some of the images below some of the lasered prototypes that we used on 930. We've got our shooter down there, for example, our shooter prototype. That's all just lasered out of masonite and some screws in there. And we were able to figure out a lot of valuable information, such as our angle, hood angle height, try to figure out different gear ratios and play around with that. And then You can also see a gearbox that ended up being our drive gearbox. So before we actually manufactured it out of what it was actually going to be made out of, we were able to test the geometry and make sure that we hadn't made any mistakes in terms of like the gear center and so forth, and that everything fit together as we anticipated it would. You can also use 3D printing. It's another very valuable resource. I have a few 3D printed parts here. And you can create what's typically known as impossible geometries for other manufacturing processes. For example, these are herringbone gears. So they're pretty hard to produce outside of 3D printing, and they're also bevel gears on the tops. So you can create all sorts of geometries that in CAD and through 3D printing that you can't produce otherwise.
So now I guess we'll start talking a little bit about OnShape and why we think it's the best CAD software out there, at least for FRC and FTC. So what is OnShape? So it was built by ex-SolidWorks developers as like a new modern CAD, kind of building in all the existing features of other CAD softwares and kind of adding on to those features. So something we like about OnShape is because it was built by SolidWorks developers, it's very similar to other CAD software. So if you're coming from a different CAD software, it takes less than 30 minutes. I mean, we used to use Inventor all the time on more robotics, and over the last season, actually during build season, we switched to OnShape, and within half an hour, and all of our CADers knew how to use OnShape, just like they knew Inventor. So something else that's really cool about OnShape is it runs on pretty much anything with the web browser. Yes, even your phone. So Chromebooks, Macs, low-end laptops, iPads. You can do everything everything you want to do in CAD, you can do on all those devices. So you can actually design parts, like full parts on iPads and phones. So if your school has those, like this is a great way to take advantage of that and not have to have a bunch of team computers or something like that. Something else that's super cool about OnShape is you can upload CAD models from other software. So if you guys were like an Inventor team or a SolidWorks team in the past, you can upload those CAD models from your existing software and you can have access to those and view those whenever you'd like. Something else that's super cool too is they have updates like every 3 weeks or every month or so. So it's constantly evolving. If there's not a feature now, maybe it'll be there in the next few weeks or so. It's pretty awesome to see that kind of development all the time. And then I think most important for this year is it's got a lot of really nice collaborative features that really help when you're working virtually or with a big team of CADers. So, but before we talk about all the really cool things, we should probably mention there's a few places where OnShape falls short. First thing, big thing is it doesn't work offline. So if you want to work on CAD, you have to be connected to the internet somehow, and that internet speed really changes how fast things load in your CAD software. So that's just something to keep in mind. If you don't have a great internet connection, it's going to be hard to use OnShape. Other little minor things, there's no revision tables in the education version. I know some teams use those a lot when you have different revisions of parts. You can like revise them and add like an entry on your drawings that shows that you made a revision. That doesn't really exist in the OnShape education version. There's no path length mentioned. So if you're a SolidWorks user and you're used to using that, there's not really anything like that in OnShape, although there are workarounds. So that's something to be mentioned. There's no real native finite element analysis support and no rendering, but those two features are not really used so much in FRC. I think there's very few teams that have really touched those features, so that's not so much of a big deal. It's more of a deal if you want to get into more advanced things in CAD. So now I guess we'll talk a little bit about the collaborative features in OnShape. So a little bit about OnShape. So one of the really cool things about OnShape is everything updates automatically for every user. So when you change one part on one computer, it'll update for everybody else who's looking at that same document. It's kind of like the Google Docs of CAD software. So as you can see in this little demo down below, on the right, I changed one of the sketches on our drivetrain. And then on the left, that's another computer, and you can see the drivetrain updates instantly, actually even before it updates on my computer. So if you're working on multiple parts at the same time, you can have like 5 people working on one assembly, and you can be changing parts and resizing things, and everybody will see that work updated instantly on their computers. Along with that, you also get autosave. So I know like a lot of times with CAD software, something will happen, you'll make a bad assembly or something, especially if you're a new CADer, and it'll crash on you and you'll lose your work, which always sucks. So it's really great. OnShape saves automatically, so there's no real way to lose your work, which is awesome. This is something that's really awesome, I think, for teaching people CAD, at least in OnShape. They have this thing called follow mode. So it's really simple feature. Basically, what it lets you do is you can go, as you see in this little video here, you can click on someone's name up in the top right corner there, and your screen will change to reflect what they have on their screen. So basically, you can use this really if you're trying to teach people, this is a great way for teaching, because you can be like showing things on your screen, and then you can have everybody else follow you, and you can be looking around at like different assemblies and looking at sketches and things, and you can be like pointing to things, and they'll see that same stuff. So you can see the cursor there and everything updates. And this is really great for collaboration too, because let's just say you're working in a part and you find an interference. Normally you would have to like call over another CADer, and you have to like look in your screen together and try to figure out what the issue is. But with follow mode, you can be remotely working on the same document. You can just double click on their name, and you can be like, hey, yeah, this part is interfering with this part. And then together you guys can work on trying to figure out how to fix that issue. So it's really great if you're trying to learn or you're just new to CAD. Really great feature in OnShape. And then something else that's really cool, version control. So this is something you don't really see with any other kind of CAD software. But basically what you can do is you can have Git style version control, if you're familiar with that from like more programming things. So basically you can create different revisions. So in this little video here, you can see we have version 1, version 2, version 3. Those are all like past versions. So maybe you can like every so often, once you get like maybe a design review or something, you can create a version so you have like something to reference to in case something goes wrong and you like revert your assembly or something. Something else that's really cool is they have something called branching. So what you can see me doing here is I'm switching between this adjustable hood branch. This is our shooter from last year in More Robotics. Midway through the season, we decided that we had a fixed shooter like angle hood design, but then midway through the season, some of the students had an idea of like, hey, there's these robots that are revealing their robots, and they have like this adjustable angle, so they can like shoot from different positions. So one of our CADers was like, I want to do that with our shooter. So we made a branch and made all the changes, and it didn't end up panning out, but all those changes were separate from our main branch. So when things didn't pan out, we could just go back and we didn't have to like try to undo 1,000 changes. It was all just in a separate branch that we could choose to merge into our main branch or use as a separate branch and just leave it separate. So awesome real feature for working together and working in parts.
All right, so next we're going to talk a little bit about some of the design features in OnShape that make it really useful for FRC and easier to design things. So one of those things, hands down, is the MK CAD library. It's a curated FRC part library, and it has most of the COTS parts that you'll use in FRC from VexPro and all these other notable suppliers. In the GIF here, for example, you can just import a 775 Pro motor with the pinion on it and the 775 Connect. The great thing is all the appearances are set up correctly, all the weights are set up correctly, and it's so much faster than downloading parts off of the internet and importing them into the software, setting the appearances, setting the weight. It saves so much time with all these different pre-configured properties. It also has configurable parts that you can change the lengths of, and other common used FRC parts, such as certain sketches for drivetrains and so forth. Another really unique thing in OnShape, which really helps speed up the process of designing things, is the ability to use part studios. So it's kind of like a combination between a typical part in a software and an assembly if you've used CAD before, because all of your parts, instead of being in individual files, are all in one place. And this helps for parts that interface together, such as if you have a hole going through 2 or 3 parts, like in this example, we're extruding a square stock through these 2 wheel halves and the pinion. And normally in a CAD software, if you wanted to do this, you'd have to do that in each individual part, and you'll have to make the same sketch on each one and extrude it through each one. So instead of doing the same thing 3 times and having the potential to put it in a slightly different place, have slightly different dimensions, or create all these interlinking references, you can have it all based off of one feature, which makes things way faster, way more efficient, and way more stable.
All right, so now we're going to talk about feature scripts. So what are feature scripts? They're OnShape spec feature. So this is something that's really great that is pretty much unique to OnShape. And basically what feature scripts are is, so feature script is a programming language created by OnShape for 3D modeling, right? So feature scripts look a lot like Java or C++. It's very similar to that, but they're designed to work with part studios and speed up modeling processes, right? And so essentially what they allow you to do is they allow you to simplify workflows, eliminate repetitive tasks, and reduce mistakes. And the interesting to note about them is many of them are designed specifically for FRC. So you'll see FRC specific options in them that are designed specifically for things that we do in FRC to make those processes faster for us. So here on the right, you can see an extrude individual feature script is being used to extrude 4 tubes of a drivetrain into 2-inch squares. And then you can see we're going back after that, and we're using a tube converter feature script on it. So that's converting all 4 tubes into Versa, or into tubes, 1/8-inch wall tubes with a Versa frame mounting pattern. So with 1/2-inch holes every inch spacing. And so you can see normally, in other CAD softwares, that would take a lot longer, whereas through feature scripts, we can do that in a matter of minutes or seconds. Yeah, so we're going to go through and look at some different feature scripts that OnShape has or that people have created. This is one example that I actually designed myself and released quite recently. So this is the plate feature script, and it allows you to create 2D plates on the fly from just a simple sketch. So you can see in this example, we're going through, so we're starting by choosing our outer geometry, and then we're going through and we're adding our holes, we're adding our motor mounting, we're orienting everything, and we're just configuring the plate very quickly and very effectively. So now our plate is all set up and good to go. And obviously in other CAD softwares, you'd have to like draw the outline manually, figure out how big your motors are, do all of that work. Whereas with the plate feature script, we can get that done in just a few clicks. Here's another really good example, rib lightning. If you've ever done lightning in another CAD software, it can take a really long time. This is probably one of the best examples of feature scripts because it just saves so much time. There's been times in the past where I've been using Creo for 930 and like I've spent, half hour plus lightening a single part. And with feature scripts, you can lighten those same parts in less than 5 minutes. And it's actually just such a lifesaver. So here on the right, you can see a part getting lightened so quickly, and it's actually just amazing. And then here we have the belt feature script. So this allows you to create belt runs. It has a lot of really awesome features. You can choose from various Vexpro suppliers, for example. So you can choose like Vexpro belts, Rev belts, Andy Mark belts. So it'll only give you those sizes of belts. It can choose the belt size automatically based on your selections. And you can also add pulleys while you're doing it. And the other great thing is it measures the distance between your selections and it compares that to your selected belt center to center. So if the two don't match, it knows that that's a problem because you're creating a belt that doesn't fit your selections, right? So then it will report a warning and then it'll tell you, hey, the belt center is wrong. So you know to go back and fix it. And when it does fix, it'll turn happy again and no longer throw that warning. So it can save you so much time. I'm sure a lot of teams have been there where they, fat finger a number while entering their belt center or center distance or something like that. They order their plate, they try to put the belt on, doesn't fit. They're like, oh no, this is not good. Not a good time, not a good place to be in, especially if it's something really important like your drivetrain. So this can really save a lot of time and really help reduce errors, which is amazing. Some other useful feature scripts, there's a spur gear feature script, so you can make custom spur gears of any size. Really useful if you're doing something like a turret or something like that. Variable libraries, you can essentially set up common measurements and sketch functions that you want to import into your part studios. So you can have useful functions like gear center to center, diametrical pitch. So you can enter like 40 tooth gear, 80 tooth gear, 20 DP, and it'll pop in the right gear center to center distance. If your team also has custom measurements that you like to use all the time, maybe you have like a 3D printing offset. Maybe you have like the perfect half-inch hex size for your 3D printer or for your machine shop. You can just have that as a variable, half-inch, hashtag half-inch hex our team number or whatever. And you can call that into all of your part studios and just drop it in whenever you're sketching. There's also custom length extrusions. You can insert all types of COTs and standard extrusions, shafts, spacers, standoffs, angle, tube, pretty much everything you want. You no longer have to like model it in. You can just drop it in and customize it right away. And there's also, and these are just a few examples of many of the different types of feature scripts that have been written. And every day there's new feature scripts getting written and developed, and it's really cool to see. And they really save a lot of time. Yeah, so in conclusion, OnShape really just has the features that make CADing faster. Probably the biggest benefit is you can spend less time designing or less time CADing things and more time designing, right? If your team currently uses CAD and your CAD team is consistently the bottleneck, OnShape could be the tool that helps push them over the edge so they can really start getting things done in a more efficient manner. The collaboration tools are also super helpful. It's so nice being able to work together on a document. You can have your mentors and your students working side by side instead of being locked onto one computer, one file version. It's also super easy to learn and switch to if you're using existing software. And for all of those reasons and more, it's just the best CAD software for FRC and for what we're doing.
So next steps. So if you're interested in OnShape, I recommend you create an education account. We'll send out these slides afterwards. We'll probably put a link in the chat after this here, but create an education account. It's free. You can actually create an education account if you're a mentor on a team too. OnShape sponsors FRC, so they definitely encourage teams to make education accounts.
There's nobody here. I decided to watch the one I wanted to watch. Okay.
Excuse me.
I think Dale, you're unmuted. Yeah.
Yeah. All right.
It's all right.
All good. Happens to the best of us. So create an education account if you're interested in playing with OnShape. It's free, easy to do. So there's a link right there. You can click on it. Otherwise, you can just search it, OnShape education account. You can create one. If you're interested in using it for your FRC team, your FPC team, there's a really awesome tutorial from OnShape themselves on how to create a team in OnShape so you can share all your documents and have everything be shared among your team. And then there's also a really, really awesome tutorial series that OnShape put on, which teaches you all the fundamentals of OnShape. So it'll teach you everything from, if you've never used CAD before, it'll teach you like sketching, how to like extrude parts, how to do assemblies, all that sort of stuff. And this tutorial is just free. You can click on this link here, you can follow it. They have lots of tutorials for pretty much every feature out there in OnShape. So this is really great if you want to get your team going right away. You can maybe show them a few tutorials and you don't have to go through all the work of making a tutorial yourself. It all exists already. And then I definitely recommend, if you're interested more in learning about like how you can really use CAD in FRC to really improve your abilities and do prototyping in CAD and that sort of thing, watch my presentation on 2D sketching in FRC. I gave this presentation maybe about a year ago or so to the Southeastern Wisconsin Revised Coalition. There's some slides here, and then I haven't found the recording from it, but if I find the recording, I'll put that link in here too. This presentation just talks about like how you can use like 2D sketching to answer questions like, are we gonna be able to shoot over a high bot? Like if, from example from last year, like if there's a tall bot sitting in front of us, can we shoot over them? Like, can we shoot over the Wheel of Fortune? That sort of thing. You can answer those sort of questions through sketching in CAD. So definitely recommend you check that presentation out. If you're interested in feature scripts, check out my brother Alex's feature script blog here. He goes into a lot of like the technical details of how his feature scripts are written and all the sort of cool features in them. So check that out. And then feel free to reach out to any of us if you have questions or want help. We all have a lot of experience using OnShape and going from different CAD softwares. I think all of us have pretty much used all the different CAD softwares out there in FRC. So if you have questions and you want to know like how you transition from like SolidWorks or like Creo or Inventor or anything like that, we can definitely help with that. So
Yeah.
All right, so we have questions now. So what we'll do is we'll answer questions for a little bit here if you have questions about the sort of things we talked about in our presentation. And then once those questions start leading more into demo stuff, we'll jump into our demo and we'll show off some of the things you can do in OnShape. So yeah, if anybody has any questions, feel free to unmute yourself and ask.
Yeah, I've got a question regarding CAM software. What do you use in terms of a CAM software? Like with Inventor, you've got HSM. You know, I know that OnShape has some recommendations like Mastercam and things like that. The downside to Mastercam is it's very expensive, and OnShape is right now for school districts $3,000 for unlimited seats. So it's actually free this year till August, but in future years, it's relatively inexpensive, but we need a CAM software that works with it. So if you have any insight on that, I'd be interested to hear it.
Yeah, maybe Everen can talk a little bit about how we do it on more, but I know at least from the Mastercam front, something that's kind of nice is every year actually FIRST gives you a Mastercam license in the kit of parts. No one really uses it, but that's another way you can look into doing it. I think Everen maybe can talk about how we do it on more in 9:30.
So actually, we still use the Inventor HSM or Fusion 360 because it is free with the educational licenses. So what we do is when we have a part that we want to use with the CNC, we download it as a generic step file and import it into the other software. And from there, use the HSM tools there that we're familiar with and generate the G code that we use on the CNC machines. It's not the best process, but it's one of the very few downsides to OnShape. But once you have the part that you're ready to CNC, you probably shouldn't really be modifying it right before you're about to CNC it. So.
Any other questions anybody has? Hope we answered your question there.
Yes, you did. Thank you.
Awesome, thank you. Okay. Yeah, if anybody else has any questions, feel free to ask. Otherwise, if I don't hear any questions, we'll probably just jump into our demo here.
Yeah, you can also post them in chat too. And Dylan will see them and we can answer them that way too.
Yeah, and if you want more information about the process specifically on how we get from OnShape to Inventor HSM, feel free to reach out to myself or Andrew in particular, and we can walk you through that process.
Yeah. Okay, yeah, so I guess we'll do some OnShape demo stuff. So today we're going to try making a drivetrain gearbox. You can see we started off with a basic sketch, just to save a little bit of time. But this is just a standard 1-inch sketch that's driving all of this. And then you can see we extruded our drive tubes, and then we used Julia's tube converting feature script to convert them into 1/8-inch tube with the 1/2-inch Versa hole pattern that we like.
Do you want to show that sketch actually, Alex, just real quick so people can
Sure.
see how simple it is?
Yeah, so this is a pretty basic sketch, just some equals constraints and things like that, and just a few dimensions, just controlling everything. But the great thing about this is if we, ever go back and want to change our drivetrain in any way, all we have to do is change these very easy to understand numbers, and we can easily reconfigure it into whatever size or length or dimension we want, which is great. Okay, so let's start. And the other thing to note is I have a use variable feature script here. So I'm importing 34 variables into this part studio. A lot of those are gear functions. There's also a few motor variables in there as well, and things like that. So you'll see those come up in the design process when we're sketching our gearboxes. Okay, so I'm going to start by making a plane and offsetting it 1.125 inches. That's just important for our design, for locating our plane away from that sketch. Okay, and then I'm going to drop a sketch in this face. So one thing you'll notice is we have multiple parts in this part studio, which is of course the benefit that OnShape allows us. Feature scripts can be accessed in every part studio. There's a toolbar right for them. So you can see I have a bunch of them added here. But what you can do is you can add custom features, and then you can go and search to the OnShape community and find all the features that you want and add them to your toolbar right there. So then you always have them right here in your toolbar for easy use. But yeah, so we're going to do some basic sketching now. Okay, let's do this. Okay, so we're going to start with the point where our gearbox interfaces with your drivetrain, which is going to be 0.75 inches up. Okay, let's see here. There's a bunch of points I have to add. Okay, so we'll have a point there, point here, and then there'll be another point there. That'll be a circle. Okay. Yeah, so these will be horizontal together. These will be vertically inlined. And basically what I'm going to do is I'm going to draw half of the points in, and then I'll come back and I'll use the mirror command to mirror everything. 1.875 inches divided by 2. That's just the Versa bearing block mount sketch deal. And then
It'll make a little more sense once you're a little farther in the sketch, but
yeah, it's a little bit cryptic just because like of what we're doing specifically. Oh, it's supposed to be 4.5 inches, and then this will be centered.
so as you can see, a lot of these tools are very similar to other CAD softwares. If you're familiar with dimensioning and line tools and that sort of thing, this is all the exact same stuff. So
Yeah. 0.25, and then this will be 1.125 inches above. We're cheating a little bit because you know, obviously this is an existing design, so it's not like anything brand new. But hopefully you can kind of see how these tools will help you. If you are working through a new design, you can go through and figure out things. So now we're going to use some sketch functions. One of my favorites is #gearOD. So this is just a function that converts the number of teeth into the actual outside diameter of the gear, right? So this will be a 60-tooth gear. So you can see that's our 60-tooth outside diameter now. Then we'll have a 30-tooth up there, a 60-tooth, and then we'll have our mounting pinion, which would be a 12-tooth. So now we can go through and assign all of those outside diameters very quickly, right? So this will be a 60-tooth again, and then we'll have another, this will be a #gearOD. This will be a 30-tooth, and this will be, oh, come on, #gearOD, and this will be our 12-tooth pinion, right? And then to assign the distances, what we'll actually use is we'll use the center-to-center version of that function. So we'll do a #gear center-to-center. So this will be between a 60-tooth and a 30-tooth gear. And this center-to-center distance will be between a 12-tooth gear and a 60-tooth gear. So very quickly, just like that, we've assigned all of our motor pinions. And then so this is our, or we assigned all of our center-to-center distances. And then this will be our falcon, right? So we'll do our falcon body diameter. So that's our falcon OD, like that. So you can see, even though I don't actually know any of those measurements off the top of my head, by using those functions, I can very quickly figure out everything that I need to know without having to go, you know, on VersaPro's website or anything like that, and look anything up, which saves me a lot of time in this case. So now I'm going to turn all of my gears into construction lines just to clean things up a little bit. And then I'm actually going to trim this down here and trim this here and then draw this arc in just because we want the plate to be defined using that point. Let's see here, center point arc. Oh, I trimmed the wrong part. Oh, my rectangle's too short. Is it?
no, I think your rectangle's okay.
Oh, you're right. Okay, I got confused by the
just gotta
sketch
draw the arc
orientation.
in.
Yeah. So we'll draw in our arc here. Oh no, come on.
So we're designing this gearbox in such a way that like covers the gear like in the bottom here. That's
Yeah.
why that arc is being drawn and some other things. It'll make a little more sense once we use the plate feature script. But basically in this sketch, we're just laying out the like what the gearbox looks like from like a layout perspective. So we're defining like those points there that Alex is working on right now. Those are like what's going to interface with the drive tube. So those are the places where bolts are going to go through and actually bolt this gearbox to that drive tube. And then all these other circles and things are just so that we know where to put the bearings and things. So that way when we put put the gears in the gearbox, everything will interface and mesh nicely. So
Right. Yeah, so now we can go through and actually make our gearbox plate, right? So we're going to do 0.25 inch plate thickness. For our fillet, we'll do 0.25 inches. And then we can add our holes. So we'll have a 1.125 inch bearing hole here and here. And then for our merge scope, we'll choose the drive tubes as well, right? So we want these holes to be going through our drive tubes, so that way we have our nice mounting. Oh, not add that one. Okay, and we'll do the same thing for 0.196 inch mounting holes. So we'll choose our sketch points here that we've defined.
if you want more like information, like how you can use this plate feature script, there's definitely some links in this presentation you can look at that'll give you like a little more background how things work. We're kind of just like trying to click through everything just to show like what you can do with OnShape. So
Right. Yeah, so now we'll add our Falcon 500 mounting holes. So we get all of our Falcons that way, and then that updates the exterior of the plate as well, which is pretty cool. And then for our angle reference, we'll choose the center here so that they point towards that. Yeah, and then we'll forego the mate connector for now. Okay, cool. So there's our gearbox plate. So now we need another one just because of this design. So I'm actually going to pattern it out by this direction. Flip it around. Oh, oops. Okay, and then we'll do our 1.125 inch offset. I guess I didn't need that plane officially. That's okay. Yeah, and then we'll do an extrude. So we're actually going to do an extrude individual of this sketch. Or we're going to do an extrude intersection. If you let me choose that region. Okay. And then we'll intersect that with our first gearbox plate to flatten it out. So our depth will be through all. So you can see it's only intersecting with that first part, even though it's technically going through this part as well. And that's because this part is the only one chosen in the merge scope. So if you choose this part, then it'll also go through that gearbox plate, but because I'm not, it won't, which saves us some time. Okay, there we go. And then now all we need is our fillet. So we just need our 0.25 inch fillet to round off these edges that didn't get filleted by that intersection. Okay,
like
so
the
there we
really
have
nice thing about how we designed this here is everything is all parametrically linked. So if you update that first gearbox plate, the second gearbox plate will update. So if you move your holes or anything like that, both gearbox plates will always mesh really nicely.
Yes.
Yeah, so far we're up to only 2 sketches, and we have, it's approaching a full drivetrain. You probably only would need 1 more to put the other bearing holes in the tube, and you'd have pretty much a complete drivetrain.
Yeah. So now we're just going to do some standard spacers. So it's one thing to note about about part studios is typically you only do 1 copy of each unique part. We're kind of breaking that rule with the drivetrain, but usually people make an exception for that, just because it's easier to do all of them at once. But that's why I'm only doing like 1 spacer, for example, because then we'll reassemble it inside the actual assembly. And there's some tools that will help us do that quickly as well, which is nice.
As you can see, you can use all kinds of different extrusions in here. So if you use like Rev extrusion or you use like FTC parts, you can just use this to really quickly create those extrusion types. So.
Yep. Right, and then you can position them really dynamically and correctly inside your part studio, which is really nice. Yeah, so there we go. So there's our gearbox plates. And then this gearbox plate will get assembled again on the outside of this one to kind of cap it off. But that's our gearbox design. So now we're going to switch over to our assembly and start doing some of the assembly work. So I'll start off by inserting everything from that part studio into its default position. And then what I'm actually going to do is I'm going to group everything except those standoffs. And the reason I'm not grouping these is just because I want to take advantage of an assembly trick to do that a little bit faster. Come on. Did I accidentally? No.
I think you're good.
Okay.
It is approaching 10:50.
Awesome.
Okay.
Thank you.
Yeah, so then I'm just going to fasten each of these in place. So one thing to know about OnShape that's different from other CAD softwares is typically assembly is done with fastens. And in fastens, you only have to choose the implicit mate to fully constrain these parts, right? So even though I'm choosing only one part on the mate, because of the way OnShape is set up, these standoffs are now fully constrained relative to each other. And if I were to like copy in this plate, for example, and fasten it to the standoff now, actually I'll do that in a moment here. First, I'm going to do all my standoffs using the replicate command. So we'll match individual edges, and then I'll drop one here, 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 and here. And then I'll do the same thing for this standoff. And we'll match all the faces on here, just like that. Nice.
So OnShape is really built to assemble things quickly, as you can see. Like the idea with all these constraints is you just have to use one constraint for every part, or maybe one or two if you have like more degrees of freedom. So you can really assemble things a lot quicker. It's not like the whole like flushing parts or anything. It's all just really designed to be streamlined and efficient.
Right.
And now this is where the MK CAD library comes into place. So Alex is currently pulling in all of the different gears and all the COTS parts that need to come together with the gearbox. And as I had mentioned in the presentation, they all have the weights assigned. They all have the correct appearances. And so it's way faster than trying to go and download everything and re-import everything and set it all up how it's supposed to be.
Right. Yeah, so obviously the MKCAD part library here, really coming in clutch. So I'm just grabbing everything I need. You can see me using these configurations to choose like the parts I want. So like you saw, like the 22 gears were all just in a list, so you could just choose the one you wanted and then insert it that way. So that made finding the right stuff really easy. This one's taking a little while because the Falcon's a big assembly. Here we go. Dum.
If anybody has any questions, feel free to stop us here. I probably should mention that.
Yeah.
So.
Okay, there we go. So there's our Falcon. Let's see here. What else do we need? We need the double sprocket for the gearbox. Where is that?
You can probably skip that. We can probably just do like the gears and things.
Okay, sure, that's fine. We'll come back to that later if we have time. Yeah, so now we can start doing
time for questions at the end. So
yeah, that's true too. Yeah, so now we'll do our big gear here, and then we'll offset it a 1/16 of an inch. Actually, that should be a -16. Then we'll flip it around so it's facing the right way. Nice. And then I'll actually replicate it onto this edge down here. So we get another big gear there. Do the same type of fasten for this. Okay, so there's our 2 gears in place. I'll do our motor.
Creating basic feature scripts is pretty easy. There's some really good documentation on the OnShape that they provide. That they have like a big help document where you can work on creating feature scripts. If you have any questions, Alex is a great resource for feature scripts. I mean, most of the feature scripts you see here in this demo here are things that he made. So he definitely knows a lot about making feature scripts. But yeah, if you have like if you have an idea of somewhere you can like simplify your workflow or something, like definitely recommend you look into feature scripts. They're a super cool tool that can really save you a lot of time and really enable some really crazy awesome features on Shape here.
Yeah.
It's a really great collaborative community as well.
Yeah, there's a lot of people, like especially in Chief Delphi, there's a lot of people that are working on making feature scripts. So if you ask on there, there's tons of people who can definitely help you out with that sort of thing too.
Right. But as you can hopefully see, oh, that didn't quite work. Okay, that's fine. I'll make a copy of this again. But yeah, so as you can see, we are putting this gearbox together really quickly. And if you're familiar with any other CAD software, you know that normally this would take way longer than it currently is taking. So by those standards, we are just flying through things right now. After this, I can go and grab my bearings as well.
Yeah, this is probably good enough for now. We'll pause and let people ask questions if they have anything. So
Yeah, I'm just gonna hide that part real quick so I can grab this fasten in here.
I don't think you fixed anything in place. This might be a problem, but
Oh shoot, right.
that's okay.
We'll
Yeah.
back up.
If anybody has any questions, feel free to ask. Let's see. Do we have anything else in the chat? I don't think so.
Yeah. Oops, I forgot to fix something in place, which is
That's
just
okay.
like grounding in other CAD softwares.
Yeah. You're going fast, but you forget about little things. But
Yeah.
yeah, it's always important when you're in assembly. You want to fix one part so that way things don't just fly off when you constrain them. So that way it knows like what thing like keep and fix in place and what things to move. So
Yeah.
but yeah, there you go. That's a basic drivetrain with a really cool little gearbox attached to it. So
Yeah.
If anyone is interested to know, that's the single speed gearbox that 930 used last year. It's designed for 8-inch pneumatic wheels, or 6-inch, sorry.
yeah. So anybody have any questions on anything?
No.
Anything about CAD design in general, or otherwise, I guess, Alex, you can keep going with the
Okay.
bearings and the sprocket.
Sure.
But yeah, feel free
Alright.
to interrupt us at any point here.
Yeah.
If-
Or you can just type in chat or whatever.
Yeah, and if you guys come up with questions afterwards, please send us emails. We are happy to help you guys in any capacity that we can. So
Yeah,
we know that this
absolutely.
year teams are going to need a lot of support. So
Yeah, I saw. Thank you, Nick, for the shout out in chat there. Definitely appreciate everybody coming, seeing your presentation. So yeah. If you're ever like curious too, to see like how other teams do things in OnShape, there's a lot of teams out there that post their entire OnShape documents on Chief Delphi. I know like 1678 Citrus Circuits, they're a team that uses OnShape. There's probably a bunch of other teams I can't think of right now, but like it's something else that's really great about OnShape is a lot of teams use it and it's all available on the web, so you can see how other teams design their parts and things just by clicking on their documents and stuff. So
Yeah. Offset 3/16 of an inch.
also one other thing I wanted to mention real quick that I don't think we actually went through is Alex is currently mentoring a team in Texas, even though he's here in Wisconsin. Which he can do because with OnShape, it doesn't really matter if you're right next to someone or you're on the other side of the nation.
Right.
Yeah.
Yeah, having follow mode is so nice for that, because you just be like, hey, quick follow me, and you can just like point out things like, oh, like check out like, like, oh, our motors are hitting or something like that. And you can just have that capability, and you can be working with someone side by side in the same document, which is also really cool. Like if someone's having an issue and you're not entirely sure what's going on, you can quickly hop into their sketch or whatever, troubleshoot it, see what's going on. You don't have to like have them download it, send it to you, download it yourself, like try to figure it out, like, so if there's like some bizarre issue, it's not like, oh, try clicking there. Oh, shoot, that didn't work. Try this troubleshooting option, and they're like new design and they don't know where any of the buttons are, and it's really hard. You can just hop in real quick and be like, oh, like, let's take a look at this. And that is so nice, and that has saved me on so many occasions. So it's just really great. Yeah.
All right. Well, I know there's a lot of other sessions that are going to be starting up, I think, in the next 10 minutes or so.
yeah, thank you everybody for coming.
Yes.
Yeah. It was a lot of fun. So hopefully you guys learned something, and maybe you guys will consider using OnShape in the future, or you've learned ways to improve your use of OnShape moving forward.